Okay, today's video is over hyperbolas. So if you'll look at the standard form equation for a hyperbola, which is shown at the top of your screen, you'll notice that the only difference between a hyperbola equation and an ellipse equation is that instead of adding the two fractions together, here we are subtracting the two fractions from each other. You'll also notice that just like ellipses, there are two standard form equations for hyperbolas. The only difference between both of these equations is the order of x and y. So if you'll take a look at the equation on the left, you'll see that x minus h squared comes first. But if you take a look at the equation on the right-hand side, y minus k squared comes first. The reason for this difference depends entirely upon whether x or y is negative. So whichever one of the variables is negative is always going to come second. So if we look at our first equation, here x is positive, hence why it's the first fraction. Y had to have had a negative coefficient in order for this minus sign to exist here. Same thing for the second equation. Y minus k squared was positive, so there had to have been some negative coefficient in front of x, and that's why we have this subtraction sign here. Another thing to keep in mind is that a squared will always go with the positive term. So here x was positive, that's why a squared goes with it. Here y is positive, that's why a squared goes with it. And then a final thing to notice is that whichever term is positive, that's going to determine the orientation of your equation. So since x is positive and since it comes first in our equation, we're going to be oriented horizontally. And in the second equation, since y is positive and it's the first thing in the equation, our graph is going to be oriented vertically. Whenever I say vertically or horizontally, I want you to think of the direction that the hyperbolas open up. So if we look at this one, they're opening from left to right, so that's why it's horizontal. And when we look at this one, they're opening from top to bottom. That's why we're going to say they're vertical. So now let's quickly go over some characteristics before we move on and start solving problems. So just like ellipses, the center of our hyperbola is always given to us by h, k. Your vertices are always going to be located on the hyperbola, and you can calculate their location by using a, h, and k. Your foci are always going to be located in front of your vertices. And then, although covertices are not listed on this table here, you still have covertices. They are just not graphed. So they do play importance in finding B, but you don't actually graph your covertices. And then these two red dotted lines represent your asymptotes, which are going to be imaginary lines that the hyperbolas don't touch. So again, key takeaway here is understanding the types of information that you're given so you can derive the standard form equation. Terms that you will be hearing for the first time are transverse axis and conjugate axis. So we need to understand what these are. The transverse axis is the distance between your two vertices, and that's going to give you 2 times a. So if you divide that distance in half, you can find a. And then the next new piece of information is your conjugate axis, which is going to be the distance between your covertices. Again, those aren't graphed, so you can't always see the conjugate axis, but sometimes they might give it to you when you're solving a problem. What you need to know is if you're given the conjugate axis, you can divide that by 2 to give you b. One other thing I'm going to point out at the bottom of the slide is this term called eccentricity. I'm not going to go into detail about what eccentricity is. All you need to know is that if they give it to you, eccentricity is a ratio of C over A. So you could figure out what C and A equals by using eccentricity. Okay, so this slide is extremely informative, and the reason why I put it together is because there is no possible way for me to go through all of the different types of problems that you can expect when you're working with hyperbolas. So basically what I did was I created a table where on one side you have your given characteristics, and on the other side you have the important information that you can get from that characteristic. For instance, if they gave me my vertices, then I know I can find the distance between the vertices, and that's going to give me 2a. And then if you look at the bottom of the slide, you're going to see important formulas that you're going to use over and over again. So for instance, there's the relationship between A, B, and C, which I will say is different from ellipses. And then you'll also be using the distance formula over and over again and the midpoint formula over and over again. So I am going to post this slide to Google Classroom along with the video so that you don't have to copy this down, but you can refer to it as you work through IXL. Okay, so here's the first type of problem that you can expect to see. It will ask you to write an equation in standard form of a hyperbola when you're given a graph. So first and foremost, let's just take a look at the orientation of the graph. I know that my hyperbolas are opening up from top to bottom. So since they're opening up top to bottom, I know I'm in vertical orientation, so my equation will be as follows. The easiest thing to find will be my center, which is going to be where both of the asymptotes cross over each other, because that's going to give me h comma k. So if we look at my graph, my center is located at 0, 0. So that means h equals 0 and k also equals 0. I also know if I look directly below and directly above the center, I have my vertices. And we also know that the distance between both of your vertices is 2 times a. So if I find that distance and divide by 2, I can find what a equals. Fortunately, because they gave us the graph, I can just count from one vertice to the next. So I have 1, 2, 3, 4, 5, 6. The total distance between both vertices is equal to 6, and if I divide that by 2, I know that a equals 3. The last piece of information that I'm missing to write my standard form equation is b, and the only way I can find that is if they give me the conjugate axis or if my co-vertices are graphed. Unfortunately, I don't have either one of those pieces of information, so the only option that I have left is by using the slope of my asymptotes. So this isn't something that I expect you to know off the top of your head, but if you review the previous slide, you'll realize that your slope is actually a ratio of a over b, specifically for vertical oriented hyperbolas. Both asymptotes are going to have the same exact slope, except one is going to be positive and the other one's going to be negative. I'm going to encourage you to only focus on the positive slope. It will make your life easier. So if we remember that slope is rise over run, that can help you figure out what this ratio is. A is going to be how far you rise, and B is going to be how far you run. So based off of this information, we know that B equals 6. Now that we have everything that we need, we can write out the standard form equation of our ellipse. So I have y minus 0, because k equals 0, squared, minus x minus 0, because h equals 0, squared. And then y will be divided by 3 squared, and x will be divided by 6 squared, and all of this equals 1. So now I'm going to go ahead and just clean up the equation and square our denominators. I don't need these zeros in the top because they don't mean anything. So I have y squared minus x squared. Y will be divided by 9. X will be divided by 36. And this all equals 1. If you plug this equation into Desmos, you'll get the same exact picture of the hyperbola shown on your screen. Okay, so the next type of problem that you could possibly see is where they don't give you a graph, but they give you characteristics of the graph. So the two characteristics that they gave us were our vertices. And if we remember, the distance between our vertices will give me 2a. So if I find that distance and divide by 2, that gives me a. And then the next piece of information is that they gave me the length of my conjugate axis. So again, you might not have this stuff memorized at the top of your head, but if you go to slide number 2, you're going to see on the table that the length of your conjugate axis is equal to 2b. So if you take that length and divide by 2, then you can find b. Finally, if they gave you your vertices or your foci or your covertices, you can find the center of your hyperbola by simply finding the midpoint between those 2 points. So none of this information is new because a lot of it mimics what you saw in the ellipse video. So I'm going to encourage you to pause here and I'm going to ask you to find A, find B, find your midpoint, which is H and K. Okay, so I went ahead and found all the variables. So I'm not going to go through my work. I encourage you to review the ellipses video if you are confused. But I got A equals 9, I got B equals 6, I got H equals 0, and K equals 0. So now I have all the information I need to write the standard form equation of my hyperbola. The last piece of information that I need is I gotta figure out if I'm vertical or if I'm horizontal. And the way that we do that is simply look at your vertices and check which variable is changing, x or y. So if I look at my vertices here, I can see that my y value in each coordinate is not changing. It's 0, 0. But then if I take a look at my x value, I'm going for -9 and I'm ending at +9. So if I pay attention here, I'm moving from -9 to +9, which means I'm going in the horizontal direction, and that tells me that my hyperbola has a horizontal orientation. So I just want to be clear about something. They're not always going to give you your vertices, so you always have to use process of elimination. If they give you your foci, then again, you just have to pay attention to what's changing between both of your foci. If x is changing, that means A goes with x. If y is changing, that means A goes with y. Or if they give you your covertices, you just have to pay attention to what's changing in your 2 points. If you have your covertices and x is changing, that means B goes with x. But if you have your covertices and y is changing, that means y goes with B. So I took all the information that was given, I plugged it into my standard form equation, and my final answer is x squared over 81 minus y squared over 36 equals 1. So this is going to be for a hyperbola with vertices at -9, 0 and 9, 0, and a conjugate axis with a length of 12. So of course, the final type of problem that you can face is having to create the standard form equation of a hyperbola when you're given a pre-existing equation. So we're going to carry this out just like we did for circles and ellipses. We're going to start by putting everything in order alphabetically and by exponent. So I have -7x squared minus 42x plus 6y squared plus 12y is equal to 99. Then I'm going to throw parentheses around my x's and around my y's. And I'm going to check to see if there's anything that I can factor out here. So I see that 7 and 42 have a negative sign and the factor of 7 in common. And then I can also see that 6 and 12 have the factor of 6 in common. So if I factor out -7 here, I'm left with x squared plus 6x. And then if I factor out 6 here, I'm left with y squared plus 2y. And then I'm just going to finish copying down what we had on the right-hand side of the equal sign. So now, of course, I'm going to complete the square. I'm not going to go over how I complete the square. You can review that in the ellipse video, or you can go on to IXL, which you already should have practiced this skill last week. So here, if I complete the square, I end up with -7 x squared plus 6x plus 9, because 6 divided by 2 is 3, 3 squared is 9, plus 6 y squared plus 2y, and now 2 divided by 2 is 1, 1 squared is 1, and if I add something to the left, I have to add it to the right, so I have to add -7 times 9 plus 6 times 1. So now I'm simply just going to factor the left side of the equation and clean up the right-hand side. So I have -7, and this is going to factor into x plus 3 squared plus 6, and this is going to factor into y plus 1 squared, and this is all equal to 42. And then I'm going to finish this off by dividing the entire equation by 42 because we want the right-hand side to equal 1. And so as I simplify everything, I end up with -x plus 3 squared all over 6 plus y plus 1 squared all over 7, and this is going to equal 1. So I'm not exactly finished, and this will explain to you what I was talking about in the very beginning of the video. So since x here is negative, it's actually going to be moved over to the second part of the equation, and since y is positive, we're going to move it to the front. So all I'm doing is shifting the order of the two fractions to give me the standard form equation of my ellipse. So my final answer is y plus 1 squared over 7 minus x plus 3 squared over 6. This is the standard form equation of my hyperbola. So following this video, you only have one IXL assignment, and all it is finding the standard form equation of a hyperbola given characteristics or a graph or an equation. So refer to the second slide of this video. It will help you tremendously.